Continuing, welcome to part 2 of connective tissue for biology of cells and tissues. So we're going to jump right in. Well, first of all, before we jump right in, again, if you are looking for all of my notes, everything that I have, link is in the description. Please go ahead and leave a like on the video if this is helping you out at all, as it helps me out. Okay, fixed cells, fibroblasts. So remember when we talk about fixed cells were created locally, and they stay locally to do their jobs. Now, these are the most common connective tissue cell type. Anytime that we see something that's the most common, the most anything, red flag should go up in your brain and say, hey, that's potentially a test question, because it's a super easy test question that, it's right there in the slides, and people are gonna sometimes just gloss right over. Their job is they synthesize type 1 collagen fibers as well as ground substance. So they're the most connective tissue type, and they synthesize the type 1 collagen fibers. And as we know, type 1 collagen is like 90-something% of all of the collagen found in our bodies. So obviously very, very common. There are two different types. I should say there's two different states. It says types, but it's more like there's two different states that fibroblasts can be in. Either they're in an active state, or they're in a quiescent or a resting state. Active state, they're making tissue, they're laying down collagen, doing all that kind of stuff. Most commonly, it's when there's tissue construction, such as a wound repair. So you get a cut or something in the skin, and your body needs to lay down more collagen in order to weave those pieces together. Think about it makes like natural stitches to kind of piece the tissue back together. And then quiescent is more the resting state, and they're shaped slightly different. You see the active form right here is very more like a star shape. The quiescent form is much flatter, more they call it fusiform shape. Fusiform or spindle shaped. Fusiform or spindle shaped. Again, here's the active one. It's got all the spikes coming off it. And the regular one, or the resting one, done. This is what we're going to talk. So the regenerative capacity, I'm just going to read this one because I want to make sure that this is super, super clear. So the regenerative capacity of connective tissue is clearly observed in organs damaged by ischemia. Ischemia is lack of blood flow. So like if you have a heart attack is cell death in the cardiac muscle due to lack of blood flow. That's what ischemia is, lack of blood flow. Inflammation or traumatic injury. Space is left after such injuries, especially in tissues whose cells divide poorly or not at all, like the cardiac muscle, are filled by connective tissue, which forms dense, irregular scar tissue. Which is why when you have a heart attack and those cells die, those cardiac cells die, the body doesn't really have a choice but to throw a bunch of scar tissue down in there. And because that scar tissue is there, it's much harder for the heart to expand to do what it's supposed to do normally. As well as with part of this is because the heart and the muscles were designed a very specific way to stretch and to fill and to move a specific way. Whenever we have injury, it throws down irregular tissue, irregular collagen. It basically just goes in and just starts chucking down collagen everywhere, trying to fill the space and keep everything knit and closed together. This is actually one of the reasons why when we have surgical incisions versus tearing. So if you think about when you talk about the birthing process, a woman who tears naturally tends to have a quicker healing time because they have irregular edges coming back together. It's easy for the body, to throw down more irregular collagen in all different directions, versus something like a scalpel slice or an episiotomy that's very precise, and there's not a lot of surface area, not as much surface area and space for collagen to throw down. It can only really be laid in one direction. So, but it's going to be throwing it down in an irregular direction, in an irregular manner, I should say. So this is also why, scars, they tend to be different colors. They can also be raised. They can look differently. I have a couple of scars. My hands, and if you can see, my camera's not great for this, but I have like this scar on my finger, slice it with a box cutter. This scar in between my fingers. Again, the camera's not great for seeing this, but anybody who has a scar, especially like a post-surgical scar, you can see like they're different. Us as chiropractors, I'm going to get into a little bit of medical application with this as well. We need to give special consideration to scars and the way that they affect the movement of the body. Whether the scars are surface level or they're super deep due to surgical, like especially if somebody has like disc fusions, or they have they've had like laminectomies, that kind of stuff. Scar tissue forms, and part of our job is to identify how that scar tissue is going to be affecting their movement. Women who have C-sections, if you want to go to more pediatric family style care, getting really good and understanding cesarean section scar massage and scar, call it manipulation. It's not an adjustment, but it's scar, like movement of scars, and how to properly show women how to move their scars to prevent the layers from adhering because of the irregular scar tissue. It makes huge differences in recovery and quality of life post those different treatments. Okay, little off subject, but really good to know, to understand, and kind of help you look forward to the future. Now, we talked about the proper connective tissue, we talked about the embryonic tissue. Let's get into these special connective tissues. We're going to go pretty quick through these, as there's just it's mostly keyword recognition. We have reticular connective tissue, adipose tissue, cartilage, blood, and bone. Starting with adipose tissue. Adipocytes, or fat cells, are responsible for storage of fats or for production of heat. So storage, production of heat. We're going to remember those two things. It's widespread in connective tissue of all regions of the body. We have what's called a signet ring appearance, a thin rim of cytoplasm surrounding a large lipid drop with a flattened nucleus right there. Nucleus, super thin layer, lipid drop in the middle. Those are our adipocytes, all these guys. So these are the cells themselves individually. When they all come together like this, we get adipose tissue. So it's a large aggregate or conjoining of adipose cells. It should account for 15 to 20% body weight of males and 20 to 25% of females. These are healthy ranges, guys. We don't want to be too far above and too far below these specific ranges. It's for energy storage, shock absorption, like the palm of the hand, sole of the foot. This is why as people get older, they tend to lose a lot of this subcutaneous fat, especially from the extremities. So old people will often have issues with the bottom of their feet and go to a podiatrist a ton, because they're losing the fat pad on their heel, and the calcaneus bone that's right down in there underneath just gets hit over and over and over and over again, and that can start to develop a heel spur, or you can also get calcification of the plantar fascia So older people, you see a lot of those things. It also helps to thermally insulate us, and it's a packing tissue that holds organs in place. There's two different types. There's unilocular, which is cells containing a single large lipid droplet, and these are most of our adipose tissue as adults. And then we also have what are called multilocular, and these are known as brown adipose tissue. These are going to be our fetal fat cells, and especially in the newborn. So the unilocular its job, you're going to have more energy production from the fat that it contains. Whereas the brown adipose tissue, it's in the newborns, and its only job is to keep the baby warm. This is why babies tend to run warmer. Babies and children tend to run warmer on average than adults do, because they have this brown adipose fat. You'll learn more about this in biochemistry, but essentially what it does, what's happening, is that with the brown fat cells has a bunch of mitochondria in it, and because it has all these mitochondria, it's burning the fat. The difference is that in the very last step, instead of creating ATP, there's a specific enzyme that turns off that ATP synthase, so it just does the whole process, giving off heat, but doesn't create a bunch of ATP. So you'll learn more about that in biochemistry. Now we have reticular cells. Reticular connective tissue, so it's synthesized reticular fibers, are composed of type 3 collagen. We talked about the reticular cells back in the collagen lecture. These contribute to the stroma of bone marrow, so the structural support framework for the organs, as well as for the bone marrow and for the lymphoid tissue, including the lymph nodes and the spleen. It's a mesh framework of the bone marrow lymphoid organs. Reticular cells making reticular fibers, creates the trabecular network in the bone, and you have lots of macrophages. So this right here was that black stained. We saw this when we were talking about our collagen lecture. Reticular cells, reticular fibers, lymphocytes, all that kind of good stuff. So these are all fixed cells as well. And we get into more of the free cells of connective tissue, the macrophages, mast cells, and plasma cells. Interesting, we didn't talk about... I don't see any slides specifically for blood and for bone. Most commonly a test question is blood is just that blood is a connective tissue. That's pretty much all they want you to remember as far as this class goes. And then bone as well. Connect it, with some of that reticular type cells helping within the bone marrow. But just bone is another one of our tissues, and you talk a lot more about bone and the structure of bone in future lectures. So we actually have a whole lecture on blood and a whole lecture on bone coming up as well. That's which is why we don't spend too much time here. Okay, macrophages, mast cells, and plasma cells. So macrophages are derived from a different type of cell called a monocyte, which are produced in the bone marrow. So a monocyte is a type of cell. A phagocyte is like a swallowing cell, an eating cell. Their job is to swallow swallow and dissolve and break down other cells that are not supposed to be there or that are no longer working. So monocytes are created in the bone marrow. They travel through the blood, and then when they finally enter into a tissue, they change into what is called a macrophage, and then they remain in that tissue until they are needed for their job. It's all part of a mononuclear phagocytic system. I kind of laid that out right there. And there are large cells with phagocytic and secretory functions as well. They're all about the immune cells. Here are what our macrophages look like. There's a bunch of different types of cells in that whole mononuclear phagocyte system. You know, the cells, the macrophages, the cells that are responsible for that kind of immune response within each of the different types of cells. We're going to cover each of these individually as we go through the different systems. So don't worry about all of these right now. We'll get to them. Just understand monocytes are in the blood, and then macrophages are in the connective tissues and bone marrow, these other places. Here's where here's what they look like. They're swallowing up bacteria, other stuff that aren't supposed to be there. Next, we have mast cells. So these are cytoplasmic, mast cells have distinct cytoplasmic granules, which exhibit what is called metachromasia, which is essentially certain parts of the cells are going to stain a different color. So we look at these different cells and see how you almost get like these little dots all through. They stain differently. That's how we identify mast cells. In the future, in a couple classes like your lab diagnostic classes, as well as another course, your general pathology course in Tri 3, you'll see a bunch of different types of white blood cells and stuff that have this similar appearance with all the different dots, but in different patterns, in different ways, in different locations, and it helps us just as an identifier for these types of cells. So the mast cells, if you ever see those little dots all like this, that is a mast cell. The granules, each of those little dots, contain mediators of inflammation, which include heparin, histamine, as well as eosinophilic chemotactic factor. Remember this word right here, eosinophilic. Eosinophilic, this is a word in the future you're going to see. You want to associate it with allergies and parasites. It'll be a little while before you see those again, but you want to remember those. You have surface receptors for IgE, which is the immunoglobulin E, which again, know that IgE is connected to mast cells. You don't need to know what it is, what is going on with it, all that kind of stuff. That's future stuff to deal with. Okay, we just need to recognize that IgE goes with mast cells and does the allergic reaction. And where they're located, the skin, the digestive tract, the respiratory tracts. If you think about that, when you have some kind of allergic reaction, what do you usually get? You usually get stomach issues, either diarrhea or vomiting. You have trouble breathing, and you also have hives on the skin. So those are our allergic type reactions. More of those mast cells. Finally, plasma cells. Plasma cells, these are large ovoid cells with basophilic cytoplasm. There's a lot of hoopla here. Things that we want to remember. The plasma cells originate in the lymphoid tissue. Then they move to connective tissue and produce antibodies that mediate immunity. So these are our B lymphocytes, our white blood cells. produced originally in the lymphoid tissue, and then they go and then they produce antibodies. It produces antibodies and a couple other key just word things. A pale halo, you might see that on a test, and then eccentric nucleus. Eccentric meaning off center. And then found concentrated in areas of chronic inflammation. We think inflammation, we think immune response. Okay, and that is our connective tissues. Again, if you have any questions, comments, concerns, drop them down below, leave a like on the video. If you need to get access to my notes, please feel free to fill out the link that is in the description as well. And have a wonderful day, and good luck studying.